All right, so in our polar functions, our inputs or our independent variable are given by the theta. And the outputs or the dependent variable are given by the r. Which is a little bit sort of backwards because whenever we write the coordinates, we write them r theta. And r is first, which whenever we write an equation in rectangular form, we usually put our y first, right? It's usually y equals something, which is our second coordinate. So it's not the same for this. But we are going to see these as r equals f of theta the majority of the time. And so let's look at this example where f of theta equals 3 minus 3 sine theta. And it is a polar function, and we are going to sketch the graph from theta from 0 to 2 pi. So you are not going to have to graph one of these by hand on the exam. It's guaranteed. They told us, I think they said that the sketching of the polar coordinates will only be asked in a multiple choice question. However, I think it's helpful to see one to see kind of what's happening here. So you're just plugging in numbers. So like here we would have 3 minus 3 sine 0. And we're just thinking about unit circles. Sine of 0 is 0. So that would give us 3. So let's graph the point. 3, 0. Our radius is 3. Our angle is 0. So the angle is 0. The radius would be 3. We would have this point right here. Then we got pi over 6. So this would be 3 minus 3 times sine of pi over 6. And sine of pi over 6 is going to be 1/2. So we got 3 minus 3 times 1/2. And we're going to get 1.5 for that. Yeah, that's fine. I'm running out of room too. There. So at pi over 6 is right here. We're going to go out 1.5. So that's going to be, oh gosh. Well, right here would be 1. It'd be half because right there is 0. So 1 would be right here. So 1.5 is like a little bit past that second circle, I think, that you see there. Oh, I've kind of graphed that first one wrong too. Because it should be halfway between 2 and 3. I was counting it like there were 4 circles there. It should really be like right here between the 2 and the 4. I don't like the way they did that, where it's like, yeah, it doesn't have like the whole numbers in between, but we can figure it out. That'll be all right. Then we got pi over 4. So that's going to be 3 minus 3. I'm going to do sine pi over 4 because I'm running out of room. What is pi over 4? Sine of pi over 4? Root 2 over 2. Root 2 over 2. So that is going to be 3 minus, oh gosh, 3 root 2 over 2. We are going to employ the use of our calculator here because to graph that, I need to know what that is. Well, where'd my calculator go? There we go. In fact, let me just go ahead and show you something here on our calculator, because this is just going to take too long. So if I do 3 minus 3 square root of 2, divided by 2. I'm going to get 0.878. Let's see, 0.878. That's going to be like here. Yeah. Let's do something on our calculator. This will make our lives a little bit easier because we still got a lot to go for plugging all these in. So your calculator will graph polar coordinates for you. So if you hit the mode button,
is it negative 8.8?
it's positive.
Oh, okay.
Yeah.
Is there a purple dot on the?
It's right here.
What's that other one in the third quadrant?
That is just 0 that is too small and looks like a point. All right.
I see what you're saying.
If you look at the 4th line on your calculator, we're going to change something you've probably never changed on these calculators. Yeah, well, this is also where you change it from radian to degree. We don't want to change it out of radians. But you're going to hit mode, which is just right beside your blue button there. And if you go down to that 4th line, you got FUNC, then PAR, POL, SEQ. This is function, which is what we've always been in, all right? You got parametric, which is in Unit 4, but I doubt we're going to do it. POL is polar. That's where we want to go. So we're going to go down here to that 4th line, go over here to POL, and hit enter so that that is selected. And now, when you go to y equals, it doesn't say y equals anymore. It says R1, R2, R3, R4. And notice, like, that button we use for X all the time. Oh, I get just batteries. That button we use for X all the time, we just always call it the X button. But out next to it, you can see that you've got, out next to the X, you've got a T, theta, pi. Those are for your other types of functions. So if you hit that X button now that you're in polar form, look what happens. It doesn't type an X, it types a theta. So we're going to just type in our equation. 3 minus 3 sine theta. And if yours is like mine and you have plot 1 turned on, it is not going to graph that. It's not going to graph correctly with that plot on. So if you go up there and hit enter, it is the X button. But when you're in polar coordinate form, it will type a theta instead. Okay. So again, also check to make sure none of your plots are on up here, because if we try to graph with it, it won't work. Yeah. All right, now I want to look at the table. I want to look at the table first, because I do want us to plot these by hand here, but the table will help us do that a lot faster. So if we go to table, press second graph. Now, depending on how your table is set up, you may be going up by whole numbers here. And that is not what we want, because we want pi over 3, pi over 2, 2 pi over 3, blah, blah, blah. So we should be able to change our table to where we can ask it, just like we do at other times. So if you do second window, oh no.
Just to clear it to where it's just like blank, because mine goes up by from 4 to 20.
Mine's blank.
Yeah, yours is already like we want it, where you can type things in. Type in pi over 3 and hit enter. I don't think I hit.
1.047.
Yeah, yours is already like we want it. So mine is not. When I go to the table, mine just has numbers, right? So I'm going to go to second window, which will take me to table setup. And I want to go down here to the independent variable and change it to ask. Like that. Yeah. And if yours was already on ask, then, yeah, yours is already on ask. And now if I go back to my table, mine will look blank, just like Lucas's did. But when I type in pi over 3, it'll give me an answer. So I got 0.40192.
Are we wanting the R1 or the theta button? value are we going for?
We want the R.
Okay. Oh, because that's probably pi over 3.
Yeah, that's pi over 3. It's just changing it to a decimal for you. So at pi over 3, which is right here, you won't have to graph one by hand. We're just trying to get like an idea of what it would look like. So we got pi over 3. It's only like 0.4, so that's going to be like about here. Okay. If we type in pi over 2, we get 0. So at pi over 2, when we go towards pi over 2, we go 0. So that's just going to be at the pole there. 2 pi over 3 is going to give us 0.40192. So 2 pi over 3. And then that's going to be like here. I bet we're going to see the pattern happen. I bet the next one's 0.878. So 3 pi over 4 at 0.878. In fact, I'm pretty sure this is going to go 0.878, 1.5, and then back to 3 right there. So if we graph those, we got 3 pi over 4, 5 pi over 6, and pi. And so we will get, I know it'd be a little bit easier to graph if it was a little bigger. The bottom part will be a little bit different. So this is going to be like 1 point something. That'll be here. And then we'll get 3 out here. Okay. And then we got to keep going around. 7 pi over 6. 5 pi over 4. 4 pi over 3. 3 pi over 2. 5 pi over 3. 7 pi over 4. 11 pi over 6, and then back to 2 pi. So hopefully we're going to see a pattern again, so we don't. So we got 7 pi over 6. Oh, that gives us 4.5. And then 5 pi over 4.
Oh, can you just, oh, never mind. I was about to say,
yeah, 5.1213. So I guess I should graph these. 7 pi over 6, we're going out. This is why he made it go out bigger, I guess, because our numbers are getting bigger. We got 4.5. So 4.5, there's 4. It's going to be a little past that. About here. And then for 5 pi over 4, we go all the way out past 5. So it's going to be more like here. Let's see what happens at 4 pi over 3. 5.598. So that is even closer to 6. And then 3 pi over 2 gives us 6. So 3 pi over 2 will be 6. And maybe we'll have a pattern. Let's see, 5 pi over 3. I bet it's going to go back down. Did I do that right? 5 pi over 3. 5.235.
Wait, no, we're looking at the R, aren't we? Be 5.591.
Oh, yeah, sorry. We are. Okay, yeah, I was thinking, why is this not working like it's supposed to? It is. Okay. Yeah, look at the R. Thank you. 5.598. And I'm pretty sure it's just going to go back down. We'll get 5.1213, 4.5, and then we'll be back at 3 for that. Let me check. Let's do 11 pi over 6, make sure that.
Right, 4.5, and then it goes straight to 3.
I think so. Yeah. and then 2 pi. Let's type in 2 pi, make sure.
There's 2 pies already out.
Yeah, 3. Yep. So, so if we graph these points, 5 pi over 3 has a radius of 5.59. Then 7 pi over 4, we're 5.12, somewhere around here. We got 4.5 for our 11 pi. And then we'll go back to 3 here. So, polar graphs have direction to them. That also makes them very helpful for different types of navigation, because you can have like a direction. If we just graph y equals x, if we just graph a line, it doesn't really have direction. But if we're graphing from 0 to 2 pi, when we graph this, we start right here at 0, and we go around like this. It does. And then you'll connect all the way around. And a lot of times they'll draw like arrows along the graph, showing which direction the graph is going, because they have a direction. Because what's going to happen, if I keep doing this past 2 pi, it starts to repeat itself. And so it just, if I do this, it keeps going on and on for that. So I think that they call this shape right here a cartoid.
Yeah, cardioid.
Yeah, it might be cardioid there. And that would be because it is a little bit heart-shaped there. Kind of like a fat heart, but it is a little bit heart-shaped. Yeah, like 2 of them together, yeah. Yeah. So, that's quite a bit of time for us to graph this, but that's the idea of what is happening. If, once again, you're not really like allowed to use Desmos on the, I think Desmos says this, if I do like r equals 3 minus 3 sine theta, it will graph in polar for you, and then you could change your background to polar for that. So that makes it really cool. Like, you can do different stuff. Like, if I square that, look what it turns into. If I change this to a 5, it would look like that. Put a 8 right there. It turns into this. Like, it makes all kinds of really cool shapes if you do stuff like this. Yes, the calculator does graph it. So if you are in radian mode, if we go to graph, oh, don't hit second, just hit graph. My window's bad. Zoom 6. The calculator graphs it. Also notice the calculator started where we started and it went around. In your window, if you go to the window here, right now my standard for this is going to be 0 to 2 pi. If I only went 0 to pi, so if I change that to pi, oh, gracious. And then I graphed it, it would only graph half of it, just that top part. So, be careful if you change this right here to a big number, it takes it forever to graph. So like if I'm going to change it to 4 pi, I don't want to make it too big. But if you change it to a really big number like 1,000, it'll take it forever to graph. Because it graphs it and then it's tracing back over it. So it won't say it's done until it gets done tracing back over it. So you got to be careful about changing that to anything really, really big. There. So, let's look at some of the types of questions that you might see. And it is my understanding that we will see these on a calculator inactive section. So if it was calculator active, you could go to y equals, and you could just type in 3 sine of 3 theta and graph it and see what it looks like. And that might be our answer. Because if I go over here and do like a cosine instead, you can see the petals like adjust differently. If it was calculator active, you could just type these in and graph them. I don't think you're going to see it calculator active though, because that would be too easy. So if you see something like this and it is not calculator active, your best bet is to think about plugging in values. So like for example, think about your unit circle. This is 0 radians. This is pi over 6. This is pi over 4. This is pi over 3. This is pi over 2, and so on, right? So at 0, so whenever my angle is 0, what is the radius at 0? It is 0. Because if we like follow this line till we hit the graph, you don't hit it till you get right there in the middle, right? So we got the point 0, 0 on this graph, which means if we plug in 0 for that theta, we should get 0, okay? So if I do 3 sine of 3 times 0, that is just sine of 0. And what is sine of 0?
0.
It is 0. So you'll get 0 for that. If I do cosine, if I do 3 cosine of 3 times 0, that gives me 3 cosine of 0. What is cosine of 0? 1. So that would be 3 times 1, which would give me 3. So are either one of the ones with cosine going to work?
No.
They will not, because they won't give you 0.00. So those would be out. The next one I would try would be pi over 6. Because right here at pi over 6, you're going to hit the graph right there at that point. So the coordinates of that point would be 3 pi over 6. Right, our polar coordinates, because it's radius and angle for that. Not our XY points, but our polar coordinates are R, theta. So if I plug in pi over 6, I want to get 3 for that. So if I try A, if I do 3 sine of 3 times pi over 6, that would be 3 times that 3's over 1. That's going to give me 3 pi over 6, which is just pi over 2. What is sine of pi over 2? Thinking on our unit circle, pi over 2 is right here.
Sine is 1, right?
1, right there, because that's the point 0, 1. So 3 times 1, that gives you 3. And that works. So A is your answer. If you do that for B, what would you get?
Negative.
You get -3, and -3 is not the correct coordinate for that. So that would be A for your answer. So plugging in points kind of is what you want to do for that. This one is very similar to what we had on the very first one. It's a lot like the first one, but it's got this extra loop right there in it. So again, I would plug in points for this. The first thing that I would do is I would check where 0 is at. So if I look, I think I've got 3 coordinates at 0. Is this right? I might have to resort to looking at his key for this.
Are these calculator inactive?
Yeah. Yeah, because their calculator active, you just got to type it in.
So you're like,
Yeah.
I got it.
Looks like I got this. This is easy. All right. I think that 0 would be, you got the point 2, 0, you got the point 0, 0, and you got the point negative 2, 0. So we got 3 different points there.
So do we plug in for sine? Do we just like...
So if we plug in the 0, we get 2 plus 4 sine of 0. And sine of 0 is 0. So that just gives us 2, which is a point.
So it's right.
How do you get the other side? Because this
Oh, you're
one,
doing that.
if we do this one, 2 plus 4 sine, or 2 minus 4 sine 0 is 2 minus 0. That also gives us 2.
We should just
2
go-
plus 4 cosine 0. This would be 2 plus 4, which would give us 6.
That's not...
So I think we're going to throw that one out.
And the other.
And then this one, now this one we can't throw out because
Negative 2.
this is going to give you 2 minus 4, which is negative 2. So I think C is the only one you can throw out.
Would 4 times 0 not be 4 and it just be 2 minus 0 would just be 2? Again.
On what?
Number on D?
Cosine of 0 is 1.
Oh.
So it's 2 minus 4 on that. So we can't really throw out anything except for C on that. So it would probably be a good idea to pick another point. Perhaps one that doesn't show up multiple times. So, like,
Are we trying to get the x value whenever, like, if you're doing it with sine? Did you plug in the y and you get the x?
yes, it's kind of like you want to plug in, because it's r theta, so you're plugging in theta, and you want to get the r that goes with it. So they're not, your coordinates aren't x and y, they're r and theta, but we're plugging in whatever we have for our theta and trying to get the r. So it's like in the x position though. So it's best to pick a point that is on grid line. So let's try this one right here. What are the coordinates of that point right there?
4.
Yeah, 4 is your radius. And what's your angle?
Oh, it's like 7 pi over 6.
7 pi over 6. So let's try that point. Maybe that will help us here. So I'm going to have to erase what I've got here because I'm out of room. So we're not going to do C because we've eliminated that one. So I got 2 plus 4 sine of 7 pi over 6. And what is sine of 7 pi over 6? Negative 1/2. And so that's 2 plus negative 2, which gives you 0. I don't know if it is, though, because
But we didn't get 4.
since you have 0, 0 right here, also, maybe that wasn't a good point to pick. I don't know.
I thought we just, are we not trying to get 4 if we plug in the 7 pi over 6?
Yeah, but if you find what's giving us trouble here is that, like, if I follow right here is 7 pi. Oh, right here is 7 pi over 6, right? If I follow that line all the way across, it hits at more than one point. It also hits at 0, 0. So I got 0, which would also be okay. Yeah.
Maybe we should try B and see if we get 4.
Yeah, let's see. And so this is going to be 2 minus 4 times negative 1/2. And that'll give us 2 plus 2, which will give us 4.
Yep. That one.
Cosine 2 minus 4. Cosine 7 pi over 6. This is going to be 2 minus 4 square root of 3 over 2. Negative square root of 3 over, no. Negative square root of 3 over 2. That one's not, you don't know what that's going to give you, but it's not going to give you 0 or 4. So that would at least eliminate D. I think technically, we're going to stop here. Because I think technically for the sake of, like, we have not really eliminated A yet.
But B's the better choice than actually.
But, yeah.
If we had the calculator, it shows that B is the correct answer.
Yeah, so we want to go with B there.
Maybe we will.
Because, and the problem is if you could get a 0 on any of these, right? Because they all cross at 0. So if you get 0, it does not eliminate it. If you get 0,
you have to do a lot. We're gonna run out of time.
Yeah, we're gonna run out of time if we keep doing that. But
On the exam,
yeah.
Now or Friday.
Yeah.
The exam's not going to do a question like that.
Yeah.
Continue on my way.
All right, let's look at 4.
Good solution.
Let's
He's
see.
gonna pull out the calculator whenever it says calculator inactive.
Yep.
Do not, because that will void your scores and possibly
I would
everyone's.
probably be better
Yeah.
than what I'm going to get anyway, so.
So do not. Yeah, but it could ruin everybody else's scores
Then we
too.
would all match.
And I read something the other day about a girl who used her cell phone just during the break and just like was texting somebody about something totally unrelated to the test. But used her cell phone during the break and they voided all of her AP scores, not just for the test she was taking. And the rest of the class was fine. They did, but they voided all of her AP scores.
Even if she had done it in the past.
It might have just been for that year, but anything she took that year,
Void as in
like no credit, sorry, doesn't count.
I don't think
So,
it's that deep.
so I think they will take up your phones and not let you have them back till it's all the way over.
How long will it take?
It'll be a 3-hour test. Yeah. I think they will take up your phones and you will not be able to get them back till it's over.
And we
But
don't
in
get
the
any
event,
extra time, right? Like 3
Right,
hours
there-
and it's like
the-
ACT. Like
right, the only way you get extra time is if like you get scheduled extra time normally during class and have like special accommodations for that. So, yeah, when it's done, it's done. Which I have been giving you guys similar amount of time on your test in class to what you will get on the AP exam. So it's not like as fast as the ACT. It should feel similar to what we do in class. It's not like for a lot of you, probably like a little more time, but it's also not like super fast. All right. There's just not time. There's not time.
It might be easy. You never know.
Yeah, we're pushing it.
We'll see. We'll see. I do.
First year?
It's the first year, and I think they're going to be a little forgiving
Whenever
on
Miss
it.
Bowen signed me up for this class, she was like, well, it's the first year they ever done it, so the exam's going to be easy.
I think the exam will be hard. I think the cut scores might be easy. Like you might not have to do that well on it to pass.
Everybody especially does.
But I think you're going to take it, and you're going to be like, these questions are hard. It's not going to be easy, but I think the level that you have to get to pass is not going to be that hard. I think that probably like on the calculus one, if you get about half of the points, it's usually a level 3. I think it'll be similar to this test, possibly.
The questions on it are going to be like the progress checks they've been creating? Because if so,
Some.
There's no way they're going to be as hard as the progress check.
They might be.
It's going to be hard.
They have released some practice tests, and we're going to do those starting Monday.
Are you
So
putting a curve on them?
yes, I'll curve them like a curve test.
Okay.
Yeah.
Wait, so the practice test count as like...
One of them is going to count. We're going to do one sort of like together, working through it together, and then we're going to do one like a test grade.
We're
So,
gonna grade it
yeah,
like our normal.
I'll grade it on a curve.
Do we
Yeah.
have test corrections on that too?
Yeah, we'll probably do test corrections on it, but it will be. We might not be able to like finish them before the exam because I'm gonna give it to you the
Well, we have
6th
weeks
and
after,
7th.
so it's not like you
Yeah, so
grade
you'll
it.
have time.
But the exam doesn't go in the grade book as a grade.
Your AP exam does not.
Yeah.
You can be exempt from this
You're
exam.
gonna get high school credit.
Yeah.
As long as you don't like.
Yeah, as long as you don't fail the class, you get high
I
school
ain't giving
credit.
up. Well, I mean, I'm trying.
Yeah. All right, let's keep going. Let's try to get a couple things done. We could keep on and on. Oh gosh. One option. Let's see. Okay, let's look at this. A portion of the graph of the polar function from f of theta equals -3 sine theta is shown on the polar coordinate system from A to B. We know A and B are between 0 and 2 pi, and we also know A is lower than B. Which of these could be the values of A and B? What I would do for this is these have to basically be like your endpoints. So if you plug in like -3 sine of 0, that's going to be -3 times 0, which will give you 0. So that would be the point 0, 0, and this definitely does hit at 0, 0. And then if you do -3 sine pi over 2, you would get -3 sine of pi over 2 is 1, so you would get -3. So that would be the point pi over 2, -3. Let's think about graphing pi over 2, -3. Pi over 2 is up here, right? But whenever we,
You scroll down so we can see that.
pi over, let's just zoom out and in. Oh gosh, not that much.
Oh, crap.
Sorry. Get back to it. Okay, so pi over 2 is up here, but if you have a negative radius, that means you go away from the graph, which ends up, or away from the angle, which means, why is it not letting me do that? Why won't it let me write? What have I done? I've done something. I think I hit that. Okay. All right. We go away from the angle, which means that we would end up right here, which are the endpoints there. So this is a possibility, but it also might not go that direction right there. So we would need to check like a point. Gosh, there's none on grid lines there.
This is not good.
Let's think. Okay, if we're going from 0 to pi over 2, think about plugging in. We can estimate. Let's think about plugging in something between 0 and pi over 2. I'd pick pi over 4, right? If I do -3 sine of pi over 4, I would get -3 times the square root of 2 over 2. And that is going to be like -3 square root of 2 over 2 for that. Now, I don't know what value that is. It should be less than 3, and it is definitely going to be a negative number, right? So if I think of pi over 4 right here, pi over 4 is right here, and if I highlight that one right there, let's use a different color, pi over 4 is right here, and if I have a negative value, pi over 4 would end up somewhere over here. I don't really know how far out it would be, but it would be over here, because I would have pi over 4 and this negative value. So while my endpoints are correct, this point would not be on the graph, so it would not be A for that. And then so I could try, I already found pi over 2, that's fine. I could look from pi over 2 to pi for that. If you think about what you would get there, really the number in between may the endpoints I think are going to line up. The number in between may help even more. So like if I pick a number between pi over 2 and pi, like 3 pi over 4, if I do negative 3 sine of 3 pi over 4, that is going to give me negative 3 sine of 3 pi over 4 is square root of 2 over 2. Yeah, it's positive. So that's going to give me negative 3 square root of 2 over 2. I really don't know what exactly that is, but I know 3 pi over 4 is here. And I know, like if I highlight that line for 3 pi over 4, I'm going to use blue right here. If I have a negative radius, that's going to put me somewhere over here, right? I'm going to end up, I'm going to go away from 3 pi over 4, so that is a possibility for that one. And then you could continue on checking for that one, and I think B is going to be your answer on that one, I think.
Yeah, because most of the lines that would go through that.
This one's too big. This goes 0 to pi, so it would be like a full sort of rotation there. I don't think that'll work. This one is also, I think, going to be too big. It's going to include more there, so I think it's going to be B for that. You know it can't be C because that's from 0 to pi, and that would include 0 to pi over 2. We already said it couldn't be that, right?
And that would be the,
And then this one is also, I think, just going to be too big. I think it's going to be like a second rotation of that. So B would be your best answer. So it's really a lot of plugging in points for that. Let's skip down to right here to talk just a little bit about rates of change in polar functions. If we have something that's positive and increasing or negative and decreasing, so sort of your signs are matching here, positive, increasing is sort of like a positive there, negative, decreasing is kind of like a negative, then the distance between the graph and the origin would be increasing. So it either means like you're going away on this side, or you could be going away on this side. If you have positive decreasing, negative increasing, if you have opposite signs there, then your distance should be decreasing. One way to think about this is to think about like what the graph of the function itself would look like. So like if I am graphing f of x equals 1 plus 2 sine x, then that would have a midline at 1. It would have an amplitude of 2. And if we kind of fill this out, where is f positive and increasing? So it's positive and increasing here from 0 to pi over 2. So 0 less than or equal to x less than or equal to pi over 2. And then positive and decreasing, that means above the x-axis, but decreasing, that is going to be all the way here to 7 pi over 6. So pi over 2 less than or equal to x. That's, yeah, less than or equal to 7 pi over 6. Negative and increasing, that is going to be, actually, let's do this. 7 pi over 6 to 3 pi over 2, you are negative and decreasing. Let's put that down here. So 7 pi over 6 less than or equal to x less than or equal to 3 pi over 2. And then, actually, we got one more thing. We got
it up there.
yeah, we got to, this is, we're negative and increasing here, 3 pi over 2 to 11 pi over 6. And we got this one last little piece that we didn't include, 11 pi over 6 to 2 pi. Which section should that go in? Positive and increasing. So we'd add that here, 11 pi over 6 less than or equal to x less than or equal to 2 pi. There.
Pi over 6 is less than or equal to x less than or equal to
2 pi. So the idea here is like when we're thinking about a polar function, think about what the graph itself would look like if we graphed it with x and y's instead. So think about like y equals 2 minus 4 cosine x, and you would think about where that would be increasing or decreasing on the function for that. So let's see, I might have time to do just this one. So like for this, need more room though. We got a midline at 2, an amplitude of 4, so this would go up 1, 2, 3, 4. My amplitude's a little messed up there. And it's a negative cosine, so you would start at like a low point, and then 1, 2, 3, 4. This would be 2 pi, and then go midline, maximum, midline, minimum there, so it would look, yeah, it doesn't let me go out of bounds there. So it would look like this, and then so you're thinking about the distance increasing for, or decreasing, so you're looking for where you're either increasing and positive, so increasing and positive would happen, use the highlighter, increasing and positive, you're increasing and positive here. Or you could be decreasing and negative, so that would be here. Those would be the cases. It looks like they didn't include this part. It looks like they just did this, which definitely right here is going to be at pi, right there. So it looks like it, oh, they gave us distance decreasing right here. Because we don't see any that are something to pi, so I don't think it's going to be either one of those increasing ones. Oh, unless that's 5 pi over 3. It could be that. Okay, I know this is wrong because of the description. Negative increasing. That's not the case. It's negative decreasing we're looking for. It's not that one. I think it's going to be, see, decreasing.
From 0 to pi.
Decreasing, we would be negative decreasing. It's not going to be this one either because your description's wrong. It's this one right here. From pi to 5 pi over 3, that's going to be this right here. You would have C. We didn't have time to do that one well. But so what I want you to do for your homework is look at the FRQ. Do the best you can on that. I will post the key. It's not up yet, but I will post it.